All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for this factoring, you're going to start by removing the 5 by multiplying it by the 20. And so you're going to have x squared plus 29x plus 100. Make sure that you replace the 5 when you go to factor. And the two numbers that we're going to want to use are 25 and then 5x plus 4, because that's what multiplies to give you 100 and adds to give you 29. So the first set will reduce. You can divide by 5, so you'll have x plus 5 and then 5x plus 4. And so that would be the answer for your factoring. For the math knowledge question, we have someone that works at the high school concession stand raising money for the math team. You can only use 1 cent, 5 cent, 10 cent, and 25 cent coins when making change. What is the least number of these coins needed to make the change totaling 44 cents? So we are going to have a 25 cent coin. We can do a 10 cent coin to get us to 35. If we did another 10 cent coin, that would get us to 45, so we can't do that, but we can use a 5 cent coin. And so that would be 40 cents, and then we would have to use 1, 2, 3, 4 1 cent coins. And so that would add up to 44, and we have 1, 2, 3, 4, 5, 6, 7 coins that we would have to use. So that's the fewest number of coins that you would need. So we're looking at lesson 76 today, dealing with symmetry. So hopefully after this lesson you will understand how symmetry works. So symmetry is a property illustrated when the image of a transformation of a figure coincides with the pre-image. So whenever your image and your pre-image coincide, that's whenever you're going to have some symmetry. There are several different kinds of symmetry that you can have. One is line symmetry. So line symmetry is when the figure can be reflected across a line so that the image coincides with the pre-image. So if you can draw a line to split your figure into two congruent pieces, then you have line symmetry with that figure. The line that divides this figure over here into two congruent halves is called the line of symmetry. So that blue line that they drew down the middle of the figure is the line of symmetry. And this figure has one line of symmetry right here. They drew it in. Sometimes you'll have more than one line of symmetry, but that one only has one. So we are going to identify whether each figure has a line of symmetry. If it does, you want to draw the line of symmetry. So the first one does not have any lines of symmetry. It is not symmetric across any line. So all we would put, no line of symmetry, and we would move on. For this one, there is a line of symmetry. It is right down the middle here. And so it says identify if it has it, and if it does, then you want to draw it. And so I drew my line of symmetry, and that's all you have to do there. Looking at another type of symmetry, rotational symmetry. Rotational symmetry is a type of symmetry which describes a figure that can be rotated about a point by any angle that's less than 360 so that the image coincides with the pre-image. On this one, the reason it says, on rotational symmetry, the reason it says less than 360 degrees, one rotation is 360 degrees. So you have to be able to rotate it less than one full rotation, and if it matches up with the image, the pre-image and the image match up, then you have rotational symmetry. So I'm going to show you, if we rotate this one 180 degrees, do you see how, aside from the blue arrow, this figure and this figure are identical? And so it has rotational symmetry. The smallest angle through which a figure can be rotated in order to coincide with itself is an angle of rotational symmetry. So the smallest angle that you can rotate your figure so that it coincides with itself is called your angle of rotational symmetry. So I'm going to go back to the last slide very quickly. We were able to rotate it 180 degrees. We turned it halfway around. And so the angle of rotational symmetry for this figure would be 180 degrees. Looking at this one, we know that if we rotated it 180 degrees, we've still got the same figure. But we can make the same figure if we just rotate it to right here. You see how it's a hexagon? And so the order of rotation on this one, well, the way you can figure that out, we rotated it once, and then we rotated it again, and it's the same figure, and then again, and then again, and again, and now we're back to our original figure. So we rotated it a total of 6 times, and an easy way to do that is to count up the number of sides, 1, 2, 3, 4, 5, 6. And so the angle of rotational symmetry on this, 360 divided by 6 would be 60 degrees. And so that would be the angle of rotation on a regular hexagon. The order of rotational symmetry is the number of times a figure with rotational symmetry is going to coincide with itself as it rotates 360 degrees. So the order of rotational symmetry is kind of related to the angle of rotational symmetry. It's the number that you divide 360 by to figure out your angle. So on this one we have 1, 2, 3, 4 sides, and so our order of rotational symmetry would be a 4. And if you check, 360 divided by 4 is going to be 90 degrees. So we want to use the triangle shown, and we want to draw a second triangle that has been rotated 180 degrees about point X. So we are going to take it, and we're going to rotate it about point X. So X and X prime are going to be at the same place. Now, we can rotate it clockwise or counterclockwise, either one. It does not matter. So what I'm going to do, I'm turning it 180 degrees, and so basically this line is going to be going the other direction. So we're going to put a dot right here at Y prime that is 3 away from X prime. And then we're going to do the same thing for Z. It's 4 away, so 1, 2, 3, 4. And so that would be Z prime. And so it gives you that figure, and it asks, does the new figure, composite figure, so 2 triangles together, have symmetry? Well, it doesn't have line symmetry, it doesn't have reflectional symmetry, but it does have rotational symmetry. And it's a rotational symmetry of 180 degrees. And the reason it's rotational symmetry, we rotated it 180 degrees. And so that's the type of symmetry that it has. Okay, so we want to look here and tell if each figure has rotational symmetry. If so, give the angle of rotational symmetry and the order. So this first one, it does have rotational symmetry. The angle of rotational symmetry, well, and the order. I like to do the order first. The order is going to be 1, 2, 3. And so 360 divided by 3 is 120 degrees. And so that would be all you would put for A. For B, it does have rotational symmetry. And we have 1, 2, 3, 4, 5, 6 peaks. So it's going to be an order of 6. And so 360 divided by 6 is 60 degrees. Now this last one, you may or may not realize how to figure that one out. We're just going to take it and rotate it. It's not the same yet, not the same. Keep rotating it around. Oop. Is that figure the same? It is. And so it does have rotational symmetry. We can rotate it twice. I rotated it once to get there, and then rotate it Another time, keep going, and I get it right there back to where I started. And so the angle of rotational symmetry is 180 degrees. So that's how those work. Looking at the next example, how many lines of symmetry does each regular polygon below have? So we've got a dodecagon. So I'm going to get the computer to draw a dodecagon for us. I'm going to do it kind of big. It doesn't go to a 20-sided figure, but we are going to use what we figure out with the 12-sided figure to figure out for the 20-sided figure. Alrighty, so we want to figure out how many lines of symmetry it has. So I'm going to use the computer to help me draw. It has a line of symmetry here and here. And I can also go through these opposite sides here and here. And I realize these aren't necessarily going exactly through the center, but they should be pretty close. Okay, so it has those lines of symmetry, but I can also go through vertices. And so I can come from here to here, and go from this one to that one, from this vertex to that vertex, from this one to that vertex. Keep working my way around the circle. I didn't do a good job with that one. And I got one more I can do. Okay, and so now I need to figure out how many lines of symmetry do I actually have. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Once I get to this one, I've already counted it, and same thing all the way around. So there are 12 lines of symmetry in a dodecagon that has 12 sides. So how many lines of symmetry will we have for an icosagon? We're going to have 20 sides because it has, we're going to have 20 lines of symmetry because it has 20 sides. Okay, so then it tells us we've got a polygon with 10,000 sides. If we had a regular one, how many lines of symmetry would it have? Well, since it has 10,000 sides, it would have 10,000 lines of symmetry. Okay? So looking at the practice problems, does the star have any lines of symmetry? If so, how many? Well, it does have lines of symmetry. We can do a line of symmetry through here. We can do it through this vertex, that vertex, and there, and also through there. And so that's 5 lines of symmetry. Okay? For the next one, the order of rotational symmetry is going to be 5. And so 360 divided by 5 is 72, and so that would be the angle of rotational symmetry. Looking at this next one, we have a triangle ABC with vertices at 0, 0, 2, 0, and 2, 3. So you want to start off by graphing those vertices. So there's our triangle, and it's reflected over the x-axis. So we are going to reflect it, and so if we reflect it over the x-axis, we have A prime and B prime that stay the same because they're on the line of reflection, our x-axis. And then C just comes down 3. And so we have C prime there. Okay, and so there is your reflected triangle. It asks if it has a line of symmetry, and if so, where is it? it does have a line of symmetry, and it's the line that you reflected it over, so the x-axis. So the line of symmetry is on the x-axis. Okay, looking at D, if we have a regular polygon with 50 sides, how many lines of symmetry would it have? Well, since it has 50 sides, it would have 50 lines of symmetry. So the answer for D would just be 50. Looking at the challenge question, name all the capital letters of the English language that have rotational symmetry. So y'all pause the video and y'all try and figure out all of them that you can. And I'm going to go ahead and write them out. So y'all pause it and then unpause it once you have all of them that you can think of. And those are the ones that have rotational symmetry. Alrighty, so that is the lesson for today. Your homework is 1 through 30, so you need to make sure to do that tonight so that we can go over any questions that you have tomorrow.